Hello everyone. Today we are going to start lecture 02 of class 8 mathematics chapter number 2, which is linear equations in one variable. In this lecture we are going to study about solution of a linear equation. Now what does solution actually mean? It means that you have to replace the variable by a particular value at which LHS becomes equals to RHS. Right. So let us formally define what is the meaning of solution. So solution is nothing but a value. Solution is a value of the variable which when substituted for the variable in an equation comma makes LHS is equals to RHS. Right. So what is a solution? Solution is nothing but a value of variable which when substituted in the equation gets LHS equals to RHS. Right. So let us take an example to understand it better. Let us take the equation to be 2x minus 3 is equals to 5. Now what does the solution here mean? That is, if you put a value of x and you'll solve the LHS, it should be equals to RHS, right? That is 5. Now let us see if x equals to 2 is the solution or not, right? Let us put x equals to 2. Put x equals to 2. Okay, then LHS is equals to 2 into 2 minus 3. So we have replaced x by 2. So we have LHS equals to 2 into 2 minus 3, which is 4 minus 3, which is equals to 1. Right? You can see clearly LHS is not equals to RHS. Clearly LHS is not equals to RHS. Why? Because LHS came out to be 1, right? But RHS is 5. So 1 is not equals to 5. So we can clearly see that x equals to 2 is not a solution of this equation. Now let me take another value and let me actually give you the real solution. Let me put x is equals to 4 in this same equation. Then if I calculate LHS at x equals to 4, then LHS would come out to be 2 into 4 minus 3, which is 8 minus 3. 2 into 4 would be 8, which is 5. Now you can clearly see LHS came out to be 5 and RHS is already 5. So LHS is equals to RHS. Right. So as per the definition, we can clearly see x equals to 4 is the value where we have got LHS equals to RHS. Right. So you can clearly see that if you have to solve an equation, you have to find that value which actually satisfies the condition that LHS should be equals to RHS at that value. X equals to 2 did not satisfy that condition, so it was not a solution. X equals to 4 is a solution. Right. Again, there are some rules to find solutions of a linear equation, right? So when you are solving linear equations in one variable, there are some rules you have to be followed. It was a very easy question in which RHS was just a number, but when you do questions, there may be terms on RHS also which contains variables, so you have to make them together, and that is where you will require these rules. So what are these rules? There are 4 rules of addition and multiplication. That is, let me combine the addition multiplication rule together and write it as same quantity. The first rule says same quantity. Now what do we mean by the word quantity? That is nothing, a number. Okay, it can be variable, it can be a number, it can be anything. Okay, but it should be same. Same quantity and number can be added or can be added to both the sides, or can be subtracted. Okay, I'm combining the rules, or can be subtracted. So the combined rule says that you can add same number on both the sides, or you can subtract same numbers from both the sides of, you can add same number to both the sides, or can be subtracted, or same number can be subtracted from both the sides of an equation, without changing the equality. That is the important part. Without changing the equality, which simply means that you can add 5 on both the sides, or you can subtract 3 from both the sides. If the variable is x, you can add 5x on both the sides, you can subtract 5x from both the sides. It should be same. Either you can add on both the sides, or you can subtract from both the sides. Okay, so this was rule number 1. This rule actually talks about two things, addition and subtraction in one rule, right? Similarly, there is a rule number 2 which talks about multiplication and division with the same quantity. That is, it states that both sides of an equation, can be multiplied by the same non-zero number, or can be divided. Either you can multiply or you can divide, but the number should be same, or can be divided. Both sides of an equation can be divided by the same non-zero number without changing the equality. Right. So both sides of an equation can be multiplied by the same non-zero number, or can be divided by the same non-zero number without changing the equality. That is, you can divide both sides by 2, you can multiply both sides by 8, but that number cannot be 0. You cannot multiply both sides with 0, because then it would be 0 equals to 0. So it would be no use. Similarly, you cannot divide both sides by 0 because division by 0 is not defined. So these are two rules which govern solution of a linear equation in one variable. Okay. Now let us talk about equations having variable terms on one side and number on the other side. Okay, this is the first type of equation, and these are the simplest. As we saw in the first part, that 2x minus 3 is equals to 7. Okay, if you take these types of equations, then they are called equations having variable on one side and number on the first side. So what is the example I just talked about? 2x minus 3 is equals to 7. Now this is the simplest form of equation you can have, right? It has variable on the first side, that is on the LHS, and number on the right side. Similarly, you can have variable on right hand side and number on the LHS. Now how do we solve this? Now remember the rules. We have to find x, so we have to keep x alone at LHS, and we have to keep all the numbers to the right hand side, and we'll find the value of x, right? To do this, we have to remove this minus 3 from LHS. So we can do that by adding 3 both the sides, because we just read the rules that adding 3 both the sides will not change the equality. Adding 3 both the sides, we will get 2x minus 3 plus 3 is equals to 7 plus 3, which will give us 2x is equals to 10. Right, now we have to remove this 2, so we have to divide both the sides by 2. Can we do that? Yes, because we just now read that dividing both the equations by same number will not change the equality. So dividing both sides by 2, you will get 2x upon 2 is equals to 10 upon 2, which essentially means x is equals to 5. So this is the solution. Now you can verify it by keeping x equals to 5 in the equation. You should always verify your answer so that you can be sure, right? Put x equals to 5 in the original equation and let us check the LHS. What is the LHS? you will find the LHS would be 2 into 5 minus 3, which is equals to 10 minus 3, which equals to 7, right? So you can see that LHS is equals to RHS at x equals to 5. So clearly x equals to 5 is a solution and it is correct. So this is how you can find the solution of equations having variable on one side and number on the other side, and then you can verify the same. Okay, so let us have some questions on this method. Let us solve 1 by 3 of x minus 5 by 2 is equals to 6. Okay, again let us take the LHS. Either you can solve the LHS together and then subtract the number. That is, you can first of all solve it and take the LCM, or you can directly apply the methods. So let us start by applying the methods, right? That is solving both the sides simultaneously. Now we have 1 upon 3 x minus 5 upon 2 is equals to 6. I am not solving the LHS, I am removing 5 by 2 from LHS. Okay, how can we remove it? By adding 5 by 2 both the sides. So using the rules of solution, we can add 5 by 2 on both the sides. That will cancel out minus 5 by 2 and we will get 1 upon 3 x is equals to. Now you can take the LCM here. LCM would be 12 because denominator of 6 is 1. Sorry, LCM would be 2, right? Because denominator of 6 is 1. So 1 into 2 is equals to 2. So 6 into 2 is equals to 12 plus 5. So we will get 1 upon 3 of x is equals to 17 whole upon 2, right? Now you have to remove this 3, so you can multiply it LHS by 3, but since you have to multiply LHS by 3, you also have to multiply RHS by 3 in order to maintain the equality, right? So multiplying both the sides by 3, you can write all the steps on the right hand side, okay, with the use of braces, and multiplying both the sides by 3. Similarly, adding both the sides 5 by 2. So now here we are multiplying both the sides by 3. So we would get numbers like this. Now 3 and 3 would cancel out and we will get x equals to 17 into 3, that is 51 upon 2, which is the solution of the equation. Now again you can verify the same by putting x is equals to 15 by 2 in the equation and checking the LHS. This LHS would turn out to be 6 and your solution would be correct. So this is how you can check the numbers. Also about writing the steps, you can write the steps as, first of all, you can either, you have two ways, either you can write the steps above and then apply it, and if you have already applied it, you can write like this: adding 5 by 2 on both sides. Similarly, here you have multiplied by 3, so you can write here multiplying both sides by 3. So this is how you can solve a question which have variable on one side of equality and number on the other side. Let us take another question so that we can have command over the method, right? Now in this we have again variable on one side, but they are also splitted. So firstly we'll try to solve them. So we have y minus 1 upon 3 minus y minus 2 upon 4 is equals to 1. So let us try to solve the LHS first, right? So taking the LCM, we would find that the LCM of 3 and 4 would be 12. Now 4 would be multiplied by this. So 4 into y minus 1, 3 would multiply like this, 3 into y minus 2 is equals to 1. Okay. You had another way. Since the LCM was 12, you could easily multiply both sides by 12 here also, but we chose to take LCM so that I can take you through different method, right? So here we will get 4 into y minus 4 minus 3 into y, and this minus 3 will multiply by minus 2, which will become plus 6 whole upon 12 is equals to 1. So finally we will get 4y minus 3y, that is y, and minus 4 plus 6, that is 6 minus 4 is equals to plus 2, whole upon 12 is equals to 1. Till now we have not used any rule of multiplication or any rule of division, addition, subtraction for solving the equation. Now we have to remove this 12, so we can multiply both the sides by 12. So multiplying both the sides by 12, we would get y plus 2 into 12 into 12 is equals to 1 into 12. That will cancel out 12 here, and we will get y plus 2 is equals to 12. Right. Now we have to find y, so we have to remove this 2. It is plus 2, so we can add minus 2 on both the sides, or we can subtract 2 from both the sides. So subtracting 2 from both the sides, we will get y plus 2 minus 2 is equals to 12 minus 2. Okay. And this plus 2 and minus 2 will get cancelled out, and we will get y equals to 12 minus 2, which is equals to 10. You can clearly verify by putting y equals to 10 in this equation and then solving the LHS. You will get 1. Okay, so this was one method in which we took the LCM on the LHS. We first solved the LHS into one term and then use the laws of solving equation, rules of solving equation. But what you could have done was you could have multiplied both the sides by 12 in this scenario, and you could cancel out the common factors. Okay, so let us move on to the next method, which is equations having variable terms on both the sides. Now in this method, what we do is we firstly try to make the variable terms on one side of the equalities, and then we can apply the above method. So how does this kind of equations look like? Let me show you this with the help of an example. Let us take 24x plus 12 is equals to 20x minus 16. Now in this particular case, we have x on both the sides. On the LHS we have 24x, and on the RHS we have 20x. So the variable x is on both the sides of equality. To solve them, first of all we will try to make it in the equation which have variable terms on the one side. So we can subtract 20x from both the sides, and we can write subtracting 20x from both the sides. Okay, so after subtracting we will get 24x plus 12 minus 20x is equals to 20x minus 16 minus 20x, which will give us 4x plus 12 on the LHS, and we will get minus 16 on the RHS. So 24 minus 20 would be 4, and 20 minus 20 would be 0. Now we can solve it, right? We have to remove 12. So what we will do, we will subtract 12 from both the sides. So we will write subtracting 12 from both the sides. So we will get 4x plus 12 minus 12 is equals to minus 16 minus 12. So we have subtracted 12 from both the sides. So the equation we will have will be 4x is equals to minus 28. Now clearly it is very easy to solve. If we divide both sides by 12, then we can both sides by 4, sorry, then we can get x equals to minus 7. Okay, so we have to write dividing both sides by 4, comma, we will get 4x upon 4x upon 4x is equals to minus 28 upon 4, which will give us x equals to minus 7. Okay, so in this way you can solve the equations having variable terms on both the sides. Let me give you an example to show how it works. So the question is x by 2 minus 1 upon 5 is equals to x by 3 plus 1 by 4, right? So now there are variable terms on both the sides, and we have to solve the equation. So what naturally we will do is we will try to bring x together and numbers together, and what we will do is we will try to add 1 by 5 on both the sides, and we do not need to do that. So there is a method called transposition method, in which we just transpose the terms on both the sides and change the sign. Let me show you how. First of all, we can make them the exact numbers by multiplying both the sides with their LCM. Now you can see the LCM of 2, 5, 3 and 4. What would be the LCM of 2 and 5 and 3 and 4? Let us find out. First of all, we have to remove the denominator so it becomes easier. Dividing by 2 we will get this. Again dividing by 2 we will get. Dividing by 3 we will get 1, 1, 1, 5, and at last dividing by 5 we will get 1, 1, 1, 1. So all of the numbers have become 1. So what is the LCM of 2, 3, 4 and 5? 2 into 2 into 3 into 5. Now it is 4 into 3, 12 into 5, that is 60. So LCM comes out to be 60. So multiplying both the sides by 60 we will get x by 2 into 60 minus 1 by 5 into 60 is equals to x by 3 into 60 plus 1 by 4 into 60. Okay. So we will have 2 will cancel 60 by 30. So we have 30x minus 1 by 5 into 60, that is 12. Okay, is equals to x by 3 into 60, that is 20x plus 4 into 60, that is 15. So now the question has become a little bit easier because denominators have been removed and we have exact numbers. How did we remove the denominators? By multiplying them by their LCM. Okay. So now we can transpose minus 12 on the RHS. Instead of adding 12 on both the sides, what we can do is we can directly take minus 12 to the RHS and we will have 20x plus 15. Now when we transpose a term from LHS to RHS or RHS to LHS, their sign changes, right? So minus 12 would become plus 12, and that is precisely the method of transposition. Okay, it saves your time. You don't have to add 12 both the sides and unnecessarily increase one step. You can directly take minus 12 to the RHS, or you can bring 15 to L. Okay, had I bring 15 from RHS to LHS, it would have become minus 15 instead of plus 15, right? So that is how you can transpose. So you will have 30x is equals to 20x plus 27. Okay, now you have to remove 20x from RHS, so you can directly bring 20x to LHS and it would change the sign. Okay, transposing 20x from RHS to LHS, we will get 30x minus 20x is equals to 27. Otherwise, what you would have done, you would have subtracted 20x from both the side. It would cancel out 20x here and it would be still 30x minus 20x. That is the same method. So we are saving one complete step over here. Okay, and how do we write it? Let me show you how do we write it. We will write it as, what we did here was transposing 20x. Since we transport 20x from RHS to LHS. So that is how, if you want to write the step, you can write the step like this: transposing 20x from RHS to LHS. What would we write here? Transposing minus 12 from LHS to RHS. That is the original form of the number. So here what we'll get, 30x minus 20x, that is 10x is equals to 27. Now again, the method of transposition works. Okay, we would divide 10 on both the sides. It would be 10x upon 10, or you can directly cross multiply 10 to the denominator. So dividing both the sides by 10, you will get 10x upon 10 upon 27 is equal to 27 upon 10. Okay, this is one step, and then you will get x equals to 27 upon 10. What would you have done is, you could have cross multiplied 10 to the denominator. That is also called transposing, right? So we can have x equals to 27 upon 10, and this is the solution of the given equation. You can again verify by putting 27 by 10 into the equation and then checking that LHS is equals to RHS or not, right? So this method of transposition saves your time. You can also directly cross multiply. Okay, but if you have any doubt, you can again use the method. Okay, it will increase the step, but it will also increase your chances of accuracy. Now let us move to the next question and use the same method here also. So we have to solve 3t minus 2 upon 4. Here variable is t. Okay, it can be x, y, t, anything. Minus 2t plus 3 upon 3 is equals to 2 by 3 minus t. Again, we can firstly remove these denominators so that the questions become easy. Now the LCM of 4 and 3, 3 and 1. Okay, there are 4 denominators, 4, 3, 3, and here is nothing, so it is 1. So their LCM is 12. So we can multiply both the sides by 12. We have 3t minus 2 whole upon 4 minus 2t plus 3 whole upon 3 is equals to 2 upon 3 minus t. Now multiplying both sides by 12, we will get 3t minus 2 whole upon 4 into 12 minus 2t plus 3 upon 3 into 12 is equals to 2 upon 3 into 12 minus t upon 1 into 12. Okay, so we have multiplied both the sides by 12. So again you can see that all the terms are multiplying by 12. Now cancelling out 4 and 12, we will get 3. So it will be 3 into 3t minus 2 minus, cancelling it will get 4. So it will be 4 into 2t plus 3. Here 3 will cancel 12 by 4, so we'll get 4 into 2, that is equals to 8 minus it will be 12t. Again solving them, we'll get 3 into 3, that is 9t, minus 3 into 2 equals to 6, minus 4 into 2 equals to 8t, minus 4 into 3 is equals to minus 12 is equals to 8 minus 12t. Okay, so this is the required equation. Now firstly we can solve the LHS and make it a bit easier, or we can easily simplify the LHS. So 90 minus 80 is nothing but just t. Minus 6 minus 12 is equals to minus 18. Okay, it is t minus 18 and is equals to 8 minus 12 of t. Okay, 8 minus 12 of t. So what you can do is, now either you can bring t from LHS to RHS, or you can take minus 12t from RHS to LHS. So let us transpose minus 12t from RHS to LHS. Then minus 12 will become plus, so it will be t plus 12t. And in the same step we can take minus 18 from LHS to RHS. So when we will transpose minus 18, it will become plus 18. So we will get 8 plus 18. Okay, this is how the method of transposition works. You can transpose minus 12t and you will get plus 12t on the LHS. Again you can transpose minus 18 from LHS and you will receive plus 18 on the RHS. So here we will have 13t is equals to 26. Dividing both the sides by 13, we will get t is equals to 26 upon 13, which finally gives us t is equals to 2. Okay, so this is how we can solve a solution. We can solve the equation, okay, which have variable terms on both the sides. So I hope it was very pretty clear. We tried to use the method of transposition so that it can save our time and steps. Okay, let us move to the next question, which is x minus 2x plus 8 upon 3 is equals to 1 by 4 into x minus 2 minus x upon 6 minus 3. Okay, so first of all, for solving it, we can remove the denominators, or if you don't want to remove the denominators, you can work out by taking the LCM on both the sides, right? That method can also work. Okay, and if you don't want it, then you can multiply both the sides by the LCM. So let us now try to solve them without taking the LCM, without multiplying both the sides by their LCM, and solving LHS and RHS separately, right? So for solving LHS, we have 3 as the LCM, so we can take it as 3 into x, because it has nothing, so it has 1 on this side. Okay, it is 1, so the LCM of this is 3, so we will have 3. So 3 into x minus, Now this minus will be multiplied on the bracket, so it will be minus 2x minus 8. This minus is now on the complete fraction, so now this negative is being multiplied to the numerator, so it will make minus 2x and minus 8. Okay, is equals to 1 upon 4. Let us solve the bracket. Taking the LCM, here it is nothing, so it is 1. Taking the LCM, we will get 6 into x, that is 6x. Now again this minus would be given to the numerator, so minus 2 and minus into minus plus x, right? This negative is on the fraction, it is not on the numerator. Now we are multiplying this negative with the numerator, so we will get minus 2 plus x. From the outside we have minus 3, right? Solving it, we will get 3x minus 2x, that is x minus 8, that is x minus 8 whole upon 3 is equals to, now what is this 1 by 4 and 6? It will become 1 by 24, right? 6x plus x is equals to, firstly we can solve the numerator, it will be 7x minus 2, and 1 upon 4 into this 6, we will get 6 into 4, 24, and here we have minus 3, right? So we can now multiply both the sides by 24, because 3 is also a multiple, 3 is also a factor of 24. Okay, so it will remove these denominators. Now multiplying both the sides by 12, we will get, multiplying both the sides by 12, we will get x minus 8 upon 3 into 24 is equals to 7x minus 2 into upon 24 into 24 minus 3 into 24. Okay, so 24 is multiplied on both LHS and RHS. With each term we will get 3 will cancel 24 by 8, so here we can write it as 8 into x minus 8, okay, is equals to x into 8 minus x is equals to, we will cancel 24 on both the sides, on numerator and denominator, sorry, so we will get 7x minus 2, and here we will have 24 into 3, that is 72. Okay, multiplying 8 inside, we will get 8x minus 64 is equals to, we will have 7x minus 2 minus 74 is minus this, minus 2 minus 72 is equals to minus 74. Now we can transpose this 7x from RHS to LHS, and we would receive minus 7x. Okay, we would receive minus 7x. Similarly, we can take this minus 64 from LHS to RHS and we'll get plus 64. So it is minus 74 plus 64. So 8x minus 7x is equals to, implies that x, and minus 74 plus 64 is equals to minus 10, which is the required solution. So again we use the method of transposition here, okay, and we got the answer. You can again put x equals to 10 in the equation and can verify that whether LHS is equals to RHS or not. Let us take one more example. Now this example is taken because it looks like it is not a linear equation. Okay, it is saying solve the equation and we are studying linear equation in one variable, but it looks that it is a quadratic equation. So let us see, is it the case or it is something else. So what we'll do is, first of all we'll take this equation and we'll try to solve the LHS. Now it is nothing but written in the form of a plus b whole square plus a minus b whole square. So let us open the whole square as a square plus 2ab, that is 2x into 3 plus b square. Okay, here a minus b whole square is equal, so it says a square minus 2ab, that is 2x into 3 plus b square. Okay, so we have opened a plus b whole square and a minus b whole square. Now on the RHS we have multiplication, so we'll multiply 8x with x. It will be at x square. Now at x into minus 1 it will be minus, it will be minus 8x. Okay, then multiply 6 with x, it will be plus 6x, and 6 into minus 1, it will be minus 6 plus 22. Okay, so we have expanded the equation on both LHS and RHS. Okay, so it will be now 4x square, 2 square equals to 2, and x square equals to x square, plus 2 into 2, 4 into 3 is equals to 12, so it will be 12x plus 3 square equals to 9. Now you can clearly see it has become a quadratic equation, but it is not quadratic. They will get cancelled out and the equation would be linear. Okay, let us firstly solve it. 2 into x square is equals to again 4x square, and we will have 2 into 3 into 4, 2 into 2 into 3, that is 12x, and 3 square equals to 9 is equals to 8x square, minus 6x, minus 8x plus 6x is equals to minus 2x, and minus 6 plus 22 implies that it is plus 16. Okay, so 4x square plus 4x square is equals to 8x square, 12x and 12x will be cancelled, and 9 plus 9 is equals to 18. Okay, then we will have 8x square minus 2x plus 16. Now what we can do is we can transpose this 8x square from RHS to LHS, and we will get 8x square plus 18. We can transpose it from RHS to LHS. So let us transpose it. It will be 8x square, and we will left with minus 2x plus 16. Now this 8x square and x square will get cancelled. So again the equation has become linear equation having variable on one side and number on the other side. So it will be 18 equals to minus 2x plus 16. Now again bringing minus 2x on the RHS and taking 18 on the LHS, we will get minus 2x will become plus 2x. So you don't have to write plus, you can directly write 2x. Okay, you can directly write 2x. Now we have taken 18 from LHS to RHS, so it will become minus 18. Okay, so 2x has become minus 2. Now dividing both sides by 2, we will get x is equals to minus 1. So this is how we can solve the equations having variable terms on both the sides. Clearly with the help of question, it was looking like the equation was quadratic and it was not linear, but as we started to solve it, it became linear and we got the solution at x equals to minus 1. So these were simpler equations. Okay, and this is how we solved it. So where there are two methods, either you can use the rules of transposition, rules of solving equation, that is you can add same numbers on both the sides, subtract same number on both the sides, or you can use transpose. It will save your steps. But remember, whenever you transpose a term from LHS to RHS or from RHS to LHS, you have to change the signs. So this was all about this lecture. Thank you for watching this lecture till end. I'll see you in the next lecture. Goodbye.